know the connective tissue cells which are fixed. Let's look at now those wandering, which are migratory. As we said, the blood, white cells of blood known as the leukocytes or the white blood cells will come to the connective tissue. They are coming from the bone marrow to their destination, connective tissue and lymphoid tissues. And there are also related cells, which are not cells of blood, which are not found as white blood cells. They are also wandering within the connective tissue. They are all to be formed from bone marrow. And when they come to connective tissue, some of them gets transformed to other type of cells. Like, for example, here, macrophages are derived from the monocytes of the blood. So they are transformed. Plasma cells are derived from the lymphocytes. So some of them are transformed, whereas some are retaining their identity, and they migrate from one place to another place. They could also go back to the blood for another destination, especially between connective tissue and lymphoid tissues and organs. And they are as listed. The first one is a macrophage. I told you the macrophages are derivatives of the monocytes of the blood. The white blood cells could be divided into 5 types. One type are monocytes, another ones are lymphocytes. The other ones are eosinophil, neutrophil, and basophils. So these are what makes the 5 types of white blood cells. Out of this, as I've told you, the monocytes are into cells known as macrophages. These specific monocytes could also migrate to another tissues, such as into the liver, into the skin, into the brain, and act like phagocytic cells. But because of those tissues, they are different in their morphology. But they are, one, derived from blood monocyte, 2, they are professional macrophage type of cells. So because of this, they are grouped together under one umbrella to be known as the mononucleated phagocytic cells or system. So you see, the macrophages are cells of mononucleated phagocytic cells of connective tissue. When they get into liver, for example, they behave differently, but at least in common, they have derived from same source. They have, again, acting like phagocytic cells. But because of their structure and their nature, they are given another name. In liver, for example, I can tell you they are named as Kupffer cells. In skin, Langerhans cells. In central nervous system, microglia, and others. At the end of the year, or at the end of histology, you will count about 8 groups of cells that belong to this category. So coming to us, our lecture of the day, macrophages are a number of such mononucleated phagocytic cells for phagocytic and antigen-presenting activities. They are wandering type of cells, but they can also become resident of connective tissue. When needed, they can also multiply and be crowded. Suppose the debris they are to dispose maybe big one, so that they could be needed as multiple cells or fused together to give us one huge cells. In such conditions, they could be named as multinucleated giant cells, or when they are multiple in number before they fused, they are named as epithelioid cells. They are acting like epithelial cells, which are crowded. These are what I can tell you about macrophages, which have pseudopodia. They are big in size, like this one, they are able to migrate. They have plenty of phagosomes and pinosomes, and you can distinguish them by such nature. Under light microscopy, it may be difficult to distinguish them clearly, but when they are stained differently, they could be marked as such. Another type of wandering cells are mast cells. They are also named differently as lamprophytes, histaminocytes. Mast cells are mainly engaged in allergic type of activities. And for this, they have a large amount of heparin and histamine, which are found in the cells as granules, ready to be released when needed. Like in condition of, for example, triggering asthmatic reaction, they play important roles. When foreign bodies are coming to the body, they regard it as a foreign, so that to neutralize it, they have to play their own important role by releasing such substance named as heparin and histamine. It happened to be this type of substances for same function also are generated from one of the white blood cells, which are also found in the connective tissue. These white blood cells are the basophils, and they are similar. They are therefore related. Structurally, they have same type of granules. Functionally, they are also engaged for allergic reaction. And biochemically, they also have same substances, heparin and histamine. And again, because macrophages, for example, are derived from blood monocytes, plasma cells of connective tissue, for example, are derived from B lymphocytes, another type of white blood cells. Originally, mast cells were also thought to be derivatives of basophils. But recent studies have shown that that's not the case. Instead, they both happen to have the same role and the same type of contents. Otherwise, they are not, one is coming from the other. Instead, both of them have the same stem cells in bone marrow. So they are formed from another ancestral one step ahead stem cells. Otherwise, mast cells are not derived from the basophils, but both of them are related. The third type of wandering cells of connective tissue are plasma cells. Plasma cells, as I'm telling you, are derivatives of activated B lymphocytes. B lymphocytes, when they are stimulated, like for example, in case of vaccination, the foreign bodies injected would reach to the lymphocytes. And these lymphocytes, when they are activated, they would produce some substance known as antibodies, which would neutralize the antigens. The activated B lymphocytes are able to divide, multiply in number. Some are retained as stem cells for next time, but some others would be activated daughter cells. These daughter cells would become producing glycoproteins named collectively as antibodies, which would neutralize the injected antigens. These antigens would therefore be destroyed by activated B lymphocytes. So plasma cells are actively engaged in production of proteins. These protein-producing cells therefore need to have large amount of 𝑑𝑨𝑹𝑚 reticular, well-formed Golgi complex, and in staining, you can see them clearly. If the staining is to mark basophilically staining 𝑑𝑨𝑹𝑚 reticulum, the cells will be highly marked. But in such a staining, the Golgi bodies would not be stained. And as a result, it would be appearing as large, lightly staining region named as hollow region near the nucleus, around where you also have the centrioles. And that's their peculiar nature. And because they are highly engaged in production of protein, they have euchromatin dispersed among heterochromatins. And the heterochromatins among the euchromatins appear as threads running from the nucleolus. Within the nucleus, we also have a well-marked and appearing nucleolus, which is shown connected with radiating type of heterochromatin, making it appear like a clock on the wall. And as a result, this type of cells are named as clock face type nucleus with clock face. So it shows nucleus which is off the center, eccentric nucleus with a clock face. So we can distinguish it as clock face nucleus. This clock face can also be named as a cartwheel. It also looks like the wheel of the cart. They named it as a cartwheel nucleus. These are the third type of cells we have as wandering in the connective tissue. Then finally, we also have all types of white blood cells. The white blood cells which come as B lymphocytes before they get converted into plasma cells are found in white blood cells. The monocytes are also there. But the remaining type of white blood cells, meaning neutrophils, eosinophils, basophils, are also found in here. So all the leukocytes are also cells of connective tissue. So you see, the white blood cells are found in connective tissue. That's the reason, for example, white blood is said to be highly related with connective tissue. Saying this much about the structural components of connective tissue in general, and saying that also connective tissue is widespread, now let's distinguish the different types of connective tissue. This connective tissue may be classified based on the types, amount, and the proportion of cells versus matrix. You can distinguish at least 4 basic, broad types of connective tissue. One type are the general or proper connective tissue. The second ones have special properties. We call them connective tissue with special properties. The third ones are cartilage and bone, again with different nature, mainly for making skeletal system of our body. We name them as supporting connective tissue. The fourth ones is blood. So there are 4 broad categories of connective tissue. In this module, today I will take you through number 1 and number 2. Number 3 would be covered, or maybe have been covered along with the skeletal system, maybe not yet covered. You cover it along with many of the muscles, and blood would be covered in another module. So let's look at first the proper connective tissue. Why we name it proper? It is because it is a general type of connective tissue. It is the widespread type of connective tissue, which could be divided based on the types, densities, and orientation of its fibers, specifically the collagen. So it is the criterion chosen now is mainly the collagen. Which collagen? Type 1 collagen. So based on the type and how it is found and its density and orientation, you can divide the widespread type of connective tissue, named as general, into loose and dense. The name can tell you, in loose, collagens are loose, in dense, collagens are dense. But it is by collagen. Had it been by cells of connective tissue, especially fibroblasts, the loose connective tissue would become dense. The dense ones would become loose. But the criterion is by collagen because of the needed function. So let's first look at loose connective tissue. Loose connective tissue is again divided into mesenchymal tissue, mucoid tissue, and areolar connective tissue, or the widespread type of loose connective tissue, which is also just taken as synonymous with loose connective tissue, because mesenchymal tissue and the mucoid tissue are very much limited, and they are both highly found during development, embryonic and fetal period. So what you have for loose connective tissue now in your body is largely areolar connective tissue, which is therefore named just synonymously as loose connective tissue. When we look at mesenchymal tissue, it is a tissue that will give rise to all types of connective tissue. Not only connective tissue, it also gives us other type of tissues such as blood vessels, blood itself, blood vessels, heart, the cardiovascular system, many other muscles are all to derive from mesenchymal tissue. So it is embryonic type of connective tissue. During embryonic period, during early development, before connective tissue has developed, mesenchymal tissue was also taking care of the function of connective tissue. It is made by mesenchymal cells. I've shown you earlier what mesenchymal cells are. So mesenchymal cells are cells of mesenchymal tissue. We just simply name it as mesenchyme. It has a very thin but abundant ground substance with few fibers. So the collagens are fewer and they are delicate in type, and it has plenty of cells, which are mesenchymal cells, which are dividing, which are just nothing but stem cells to give rise to all connective tissue cells, as well as other related cells as well. Then mucoid tissue. Mucoid tissue again has stellate cells, thin collagen, but abundant soft and jelly-like viscous type ground substance, mainly with large amount of hyaluronic acid. It looks like the mucus coming from the nasal cavity. You know, mucus, it is very thick, viscous type, and it is most abundant during development, specifically packing the umbilical vessels. You know, during development, the fetus swimming in a liquid with an amniotic cavity is connected for its metabolic need with the wall of the are you with me? I let you? Hello? Okay. Because the lights had blinked and I thought the light has gone, and the internet in such cases would automatically be disconnected. But we are lucky so far, we are not being disturbed. So you see this umbilical vessels, 3 vessels, 2 umbilical artery and 1 umbilical vein are connected from the fetus to the wall of the uterus. And these delicate vessels need to be packed. And for such packing, mucoid tissue is the appropriate one. And in such condition, it is named as jelly, Wharton's jelly. So that's where we have it mainly, but we also have it in us between adjacent vertebrae. There are intervertebral discs. You may have heard of this in anatomy. This intervertebral disc is separating one bone from the other bone, acting like a cushion. And this intervertebral disc has 2 components. Centrally, there is a nucleus pulposus made by this mucoid tissue. It is same as the toothpaste. You know, for brushing your teeth, you have that toothpaste. It looks like that. But it has to be surrounded by tough collagenous type of cartilaginous type of tissue from outside. So this is where again you can find it, but it can also be found in a pulp of young teeth. So you see, we don't have it as such in us, except nucleus pulposus. It all be found during development. Otherwise, the bulk of loose connective tissue is coming as areolar connective tissue. And that's as follows. Let me get my next slide. Again, my laptop is stuck at some time. I couldn't get the next slide, but hopefully it comes soon. Oh, it's not coming. I can tell you those areolar connective tissue is the connective tissue I have taken as a model to show you my today's lecture. That diagram, you see, this photograph I've shown you is just a photograph of areolar connective tissue. It is the most abundant type of loose connective tissue. It contains almost all structures I have described to you for the connective tissues this morning. All the 3 types of fibers, all the 8 types of cells I mentioned to you are all found in there. The ground substance is just like I've told you, thin, fluid, viscous type of substance, collagens are there, elastic are there, everything is there. And where do we find it? We find it, good example again I can give you is the superficial fascia. You looked at gross anatomy, but it is also found packing one thing with another, making the neurovascular bundle, the vessels, the nerves. In order to reach to the different organs, they have to be surrounded, they have to be supported, they have to be packed by loose connective tissue. So that's what it looks like, and it is highly vascularized. It contains various types of connective tissue cells, and it is just nothing but like what we have been describing so far this morning. That's what it is. We call it areolar connective tissue, but we can also name it just as loose connective tissue. Good example for you is the superficial fascia. But also when it gets into different organs, the different organs need to get their own blood vascular system. They need to get their innervation. Such innervations would be wrapped by such loose connective tissue. So the occurrence of loose connective tissue is therefore widespread. If you are looking liver, with the liver, you have loose connective tissue surrounding the blood vessels, the nerves, separating it from one thing from the surrounding. When it is very dense, when the collagens are dense, when it needs to be dense, we call it dense connective tissue. But otherwise, when it is loosely, when it is delicate, it is just areolar type of connective tissue. Then we have dense connective tissue, which is same as loose connective tissue, but has less amount of cells because cells are now restricted mainly to fibroblasts and fibrocytes. The ground substance is also less in amount. At the expense of this, we have more collagen, which are coming mainly as fibers and bundles. And this type of connective tissue is rather for strength, where it is needed to support the tissues in a more stronger type of fashion. Like, for example, making the capsule of organs. The liver, for example, needs to be surrounded by relatively denser type of connective tissue. And it has to be partitioned by denser type of connective tissue, from where branches are making delicate to give us loose connective tissue. Good example, if you have a reflected skin in gross anatomy again, this dense connective tissue is represented by deep fascia. You probably have seen deep fascia. Deep fascia is stronger than superficial fascia. So deep fascia is just nothing but dense connective tissue. Again, this dense connective tissue is needed for sake of withstanding tension. But it depends now on that particular tissue, whether it is required to withstand tension coming from a given direction or from all different directions, so that collagens be needed according to the tension generated. I'm telling you, collagens need to be laid down against the tension to withstand the tension. If tension is coming from one direction, the collagens should be laid down in such one direction regularly. So they would give you regular dense connective tissue. If the collagens are needed to be deposited against the tension coming from different direction, they are to be laid down irregularly. We name it irregular dense connective tissue. Therefore, you see, dense connective tissue has two varieties. One is irregular, another is regular. I will give you two good examples and you would more understand it. Like, for example, if we begin with irregular dense connective tissue, this type of irregular dense connective tissue is best represented by the dermis of your skin. You see, the skin we have covering our body is made by two tissues. The overlying tissue, the overlying covering, we have finished about it last time. It is made by stratified, squamous, keratinized, stratified, keratinized, squamous type of epithelium. It is made by a type of epithelium that withstands mechanical damage, mechanical reason. And then underlying this, we need the collagens to be deposited to withstand the tension coming from different directions. Your skin is subjected not to tension coming from only one direction. You are working your day-to-day activities against different tensions. When you are washing your hand, the tension is coming from different directions. So the underlying dermis should have to have its collagen laid down in different directions. Like in here, the region indicated by DDD, the reddish outline are indicating collagen. And dispersed dark-like outlines are indicating the fibrocytes and fibroblasts. But within this dermis, we also need to have loose connective tissue, because within it, we need to have blood vessels. And even in this skin, we say the blood vessel in dermis is not needed only to support itself, but it is also reason to support the overlying epidermis, because epidermis is epithelial tissue. So you see, look at towards the junction with the epidermis, region has relatively large amount of cells. This region is loose connective tissue. The reddish outline marking the collagens are not as many as they are found in the deeper. So this region is made by loose connective tissue. Only at the junction where we have relatively large amount of blood vessels. I've told you loose connective tissue has relatively large amount of blood vessels. Dense connective tissue has a small amount. So this region is loose, but remaining larger part of dermis is dense, irregular type of connective tissue. But within it again, look at this region. If you are following my pointer here, look at this region is highly cellular. This region is highly cellular. These regions are blood vascular system. In this region, you have blood vessels, or maybe ducts or glands, sweat glands are found in those regions. In such regions, you have more of loose connective tissue. I told you loose connective tissue is found in many organs for reasons of packaging the neurovascular structures, the ducts of glands, the gland itself need to be supported by loose connective tissue. So such regions are representing loose connective tissue, but other remaining regions are representing the dense, irregular type of connective tissue. Then dense regular type of connective tissue. A good example for dense regular connective tissue is the tendon. Tendon. You see, tendon is connecting muscle to bone. Muscle is contracting towards one direction. You know that from your anatomy. So because of this tension coming to the tendon from a given direction, the collagens in the tendon need to be laid down in a uniform pattern. If you cut this in longitudinal plane, you see it like this. If you cut it in cross section, you see it with a good pattern like this, which are showing mainly this time the collagens are not as such well stayed, but look at the dark like patterns, outlines, which have good dispersed, uniformly dispersed pattern. These are the fibrocytes. When you look at these fibrocytes in dense irregular, like the previous one, look at this. They have no as such well uniform pattern. But when it is dense, you can see it. So even in cross section, you can tell difference between dense regular and irregular connective tissue. When it is longitudinal, you can even see it very more clearly. The dark ones are the fibrocytes and fibroblasts. The reddish and light grayish outline are to mark the collagens. In between, regions where you have plenty of cells relatively, like these ones, like this one, like these ones, these are regions of loose connective tissue. The remaining greater part is dense regular connective tissue. So you see, loose connective tissue can come by its own separately, or it could also be found even within dense connective tissue. Let's leaving even its occurrence in plenty of other additional vascularized type of organs. That's what I can tell you about general or proper connective tissue. Then let's look at connective tissue with special properties or special connective tissue. We can divide them into three categories: reticular connective tissue, elastic connective tissue, adipose connective tissue. All these have been covered. Just like when I covered mesenchymal tissue, I just simply told you that the cells are mesenchymal cells. I already told you, I said mesenchymal tissue is the tissue of embryonic tissue because it is the one which gave rise to all connective tissue. So this type of thing had simplified our discussion of mesenchymal tissue because we were just mentioning it now. These are also mentioned. Reticular connective tissue, you have to think that it has reticular cells and reticular fibers. I have already finished this. I have already told you that. Elastic connective tissue, you have to think that it has to have large amount of elastic fibers. Adipose tissue has to have adipose cells. It could be white or it could be brown. So we also have already finished about this one, but instead of leaving this for you to read, let me just cover this briefly in a few slides. Reticular connective tissue is with large amount of reticular fibers, which are making the stroma. These are to be taken care of by reticular cells. What are reticular cells? I've already told you. What are reticular fibers? I've already mentioned. But they are just found as networks. Why do we find them as such, to make a stroma? In what type of tissues? Delicate organs such as lymph nodes, liver, glands. Many of the glands have such reticular connective tissue. What do they look like? When you see them in properly stained organs, you may not be able to see them clearly because of the parenchymal cells are the most prominent ones. But in special staining, if you make the parenchymal cells invisible, you can see them. You see, like this. Just like in a classroom, when students are all found in that class, you don't see the chairs, you don't see the stool. The benches are not very clearly visible because they are covered by the overlying people, students. But when students are made invisible, maybe when they are out of the class, you can see the seating place. It is same as that one. So in order to see the stroma, in order to see the reticular connective tissue, you have to stain in a way that makes the reticular connective tissue visible and the parenchymal cells invisible, or sparse regions, like in this diagram, photograph. It is a photograph, it's not diagram. Here, you can see the round-like structures are the lymphocytes in a lymph node. In regions where the lymphocytes are sparse and the background is clearly visible. The network type of the thread-like, the fibrous type of structures are representing the reticular fibers. The reddish or brownish type of outline, like this one here, with lightly stained nucleus, like these ones, like this one, like this one, the reddish outline, like this region, is marking the reticular cells. So the reticular cells are visible at the background. And this is what it looks like. Then elastic connective tissue. This elastic connective tissue has, as its name implies, large amount of elastic fibers which are coming as thick, even bundles. They are bound together. They are running as a thick, wavy, like parallel bundles. And this also need to have loose connective tissue. The reticular connective tissue I told you earlier need also to have loose connective tissue. These ones also need to have such loose connective tissue. And the cells are mainly fibroblasts, fibrocytes. The ground substance is less in amount, and this is highly elastic. And we find it in tissues which are needed to be elastic. You would study this in different regions, like there is a ligament known as ligamentum flavum. When you study the cervical vertebrae, you see them there. In other elastic tissues, you find them more than the other tissues. Then finally, the adipose tissues, which come as white and brown. White adipose tissue is populated by white adipocytes. Brown adipose tissue is populated by brown adipocytes. I've shown you this picture. And white adipose tissue is unilocular. It could be yellowish because of large amount of carotenoids, I told you. Where we find it? Mainly in subcutaneous tissues. But you can also find it in some organs. This organ is, for example, parathyroid gland, packing it, surrounding it. Within the gland itself also, you can have it. And they have their own preference location. But mainly you find it in subcutaneous tissues. When you reflect the skin around the superficial fascia, you have seen how your dissecting hand gets just lipidy, fatty. It is because of such abundant white adipose tissue. Their main purpose, function is insulation. They insulate the body, they protect us from getting cool. They are also important for mechanical packaging. They are energy storage sites. They are shock absorbing type of cushion-like, pad-like substances. And these days, in addition to all this, they are also found to produce many and important secretory products. So they are also regarded as endocrine glandular cells. And they have plenty of roles in, for example, causing obesities and weight gain and things like that. So you study this in other disciplines. Otherwise, previously, all their functions were mainly rotating around all these four listed ones. But these days, their secretory activities have also been given importance because of the important functions from the secretory products produced by these cells. The brown adipocytes appear like this. They are with multiple vacuoles. They are also brownish in their staining. They also less abundant. They are with occurrence in conditions such as, for example, energy as well as heat are combined needed in case of neonates, I told you, as well as hibernating animals. So we have them in such conditions, but they are not as abundant as that of white adipose tissues, but you can find them dispersed among the white adipose tissues as well. You may even see them together. I remember one slide we used to demonstrate, use it as a demonstration slide in histology lab. From one slide, you can see side by side white adipose tissue and brown adipose tissue around the kidney. So you can find it. Then I would not describe it in this module. Otherwise, other division of connective tissue, as we've said earlier, include bone and cartilage, making the skeletal system, are also part of connective tissue. They have their own modification, and because the modification is so high, and they are found on the skeletal system. You would see them in a module that is dealing with skeletal system. We also have blood, which may be considered and be grouped as the fourth type of connective tissue, because it is related to connective tissue, one, level of mesenchymal tissue. But there are also other tissues which are not connective tissue, so you may question this. But more than its development, the cells are the reason, because cells are contained in the as white blood cells in blood are also cells of connective tissue, so they have similar cells, and in this case they group them under connective tissue. But some people question this because there is no clearly visible fibrous type of structures in the connective tissue, and the ground substance is so liquidy, and so because of the matrix is so highly liquidy, they would tend to take it out. So some people, some authorities may regard this one not to group it under connective tissue. In such cases, they would take this blood as a fifth tissue of the basic tissue of our body. You remember, in our body, we said the tissues are also classified into four. Incidentally, the connective tissue, when you take blood into connective tissue, incidentally is also classified into four. But when you come back to the basic tissues of our body, which we said include one, epithelial tissue, second, connective tissue, third, muscle, fourth, nerve. But if you take blood as another out of connective tissue, you have to consider the basic tissues in our body to be five. So some would take blood as a fifth basic tissues in our body. Some others would take it under connective tissue. Whichever you may be comfortable, blood will not also be covered in this module because it is our other tissue. So saying this, with this, I have finished my lecture for the day. If you have any question, feel free to ask or chat. Otherwise, from my side, I've finished my discussion. And if you have anything to chat, do so. Otherwise, I will send the PowerPoint to you, and I know you also get the recorded copy of my lecture. So thank you. That's all I can tell you. So we meet tomorrow for the nervous tissue and the neuroglia. Is there anything you chat or you leave? So I don't see anything in the chat. So the class would end with this, and we meet tomorrow at 8:30 again, same time as today. Thank you. I'm leaving now, ending the meeting.